Welcome to qnawire.
Here we're told the plane is flying on a straight horizontal path at a constant speed of 332.53 kilometers per hour, and you see the campus of McMaster University in Hamilton at an angle of 3.89 degrees below the horizontal, and then after 4.55 minutes passed, you see the campus, well, the pilot sees the campus at an angle of 8.70 degrees below the horizontal. With this information, we want to know what is the height at which the plane is flying above the ground. So in order to do this, what we're going to do is, first of all, we want to know what is going to be the distance in between the 2 points in order to apply some geometry calculations. In this case, what we're going to do is employ the law of sines, because we're going to be able to know the sides of this triangle. In addition to that, we can already write down what are going to be the angles corresponding to the internal angles of this guy. We can also find the angle on this outside triangle from our drawing. Notice that this is the line that the pilot would see from the first point, and we can calculate all of the angles because we know that this is a straight line, right? So the first one that we're going to get is going to be this internal angle. This is going to be 171.23 degrees. And since the sum of the internal angles of a triangle need to be equal to 180, we know that the last one, the one down below here, needs to be equal to 4.88 degrees. In addition to that, we know that this needs to make a straight angle, so 90 minus 3.89 is going to give us the angle that we have left on this outside triangle. Let me put it in red, because we're going to use it at the very end. So this is 86.11 degrees. Okay, so now with all of this information, we just need to know what is going to be this distance over here. So distance is velocity times time. In this case, the velocity is in kilometers per hour. But our time is in minutes. So we need to employ a conversion factor from minutes to hours. So 60 minutes is equal to 1 hour. In this way, we're going to get the distance directly in kilometers, as you can see, from the cancellation of the units. So the result in here is going to be equal to 25.217 kilometers, rounding up to five significant digits. So now that we know that distance, we can apply the law of sines. Remember that the law of sines tells us that in a triangle, we can always find these kind of relationships for finding one of the sides. In this case, for us, alpha would be equal to 171.23 degrees. Remember that alpha is going to be the angle that is right in front of the side that we want to know. In this case, we wish to know the hypotenuse of this triangle over here. Beta is going to be the angle associated to the opposite side of the one that we know. So in this case, the side B would be this value for distance that we already calculated, and would be equal to 4.88 degrees. And finally, B would be the distance that we got, 25.217 kilometers. So after substituting in our equation, the side A is going to be equal to 25.217 kilometers times sine of 171.23 degrees. Let me go down a little bit. Divided by the sine of 4.88 degrees. The value for the distance that we got here is going to be equal to 45.196 kilometers. And finally, in order to know what is going to be the height, we can employ another trigonometric relationship, but now with this external triangle that we got. I'm just marking it red just to make it clear that we're employing that as reference, and the angle that I'm going to pick is going to be this one, 86.11 degrees. So what trigonometric relationship relates the adjacent caret, which corresponds to the height, with the hypotenuse, that is going to be the cosine. In this case, from our drawing, cosine of 86.11, was it? Yeah, 86.11 degrees is going to be equal to adjacent caret, which is h, divided by a. So if we want to know the value for h, it's going to be a times cosine of 86.11 degrees. So h is equal to equal to 3.066 kilometers. So with that, it would be all. The only thing that you might check if you want is if the drawing provided by your professor is different than this one, then the result may vary. But by reading the problem, that should be the correct drawing. So another thing that you can do just to verify the problem is apply the law of sines to get this side over here and calculate the height, employing the sine of the angle of 8.77 degrees, and you're going to find that the result is going to be exactly the same. Just for reference, I did that just for checking up, but it is not strictly necessary. This side is going to be equal to 20.11012, and again, applying sine of 8.77 times this value, you're going to get the same value for the height, which is 3.066. Yes, 3.066. So both are going to be correct methods to solve the problem. With that, it would be all. Thank you very much and have a good one.